Hi everyone, part 4, slope point form for the equation of a linear function. Another way of writing the equation of a line is called point slope form. Okay, and the formula for that is on your formula sheet. It is y minus y1 equals m bracket x minus x1. Okay, again, this equation is on your formula sheet, so you don't have to memorize it. Okay, this equation is called slope point form because both the slope and the coordinates of a single point on the line can be identified from this equation. It's really just an algebraic manipulation of the slope formula. Okay, so let's develop this. Okay, so consider the graph to the right. Okay, so this little graph here, yay. Okay, the line has a slope of -3 and passes through the point -2, 5. Okay, if we find any other point on this line, so Q, we called it, and we call it XY. So just any other general point. See, it's right in the middle of nowhere too, so you can't just, you could have picked another point somewhere else. But anyways, we don't actually want the numbers for it. We want it to be XY. So if we figure out the equation using that XY, look what happens. So slope is rise over run. Okay, so let's make this, so that would be x2, this would be y2, make the 2x1, the 5y1. So the slope would be y minus 5 over x minus minus 2. Okay, so minus minus 2 makes a positive 2. So the slope is y minus 5 over x plus 2. Okay, great. Now, and we know that the slope is -3. Okay, and we were told that, but if we weren't told that, we could figure it out. Okay, so look, if I take this bottom x plus 2 and just multiply that up, look what I get. I get y minus 5 equals -3 x plus 2. Oh. Okay, so the final equation then, okay, y minus 5 equals -3 x plus 2. Okay, notice a few things. Okay, the slope is easily identified. The slope is -3. Now, the original point was -2, positive 5. So there's a 5 in the equation and a 2 in the equation. So both numbers are present, but what do you notice about their signs? So look, this was -2, 5. That's the point it went through. So we have x plus 2. So it was -2, 5. So now I've got an x plus 2 and a y minus 5. So both signs changed. Interesting. So the thing is, if we use that, that's going to be the same for all of these. So if we look at this, the points are going to just change. So the x point would be -2. The y point, so it's -5, so we change the sign, so it's positive 5. So I can tell the slope, really easy, and 1 point on the graph. Okay, and remember, once you have the point, you just draw that on, so here at -2, 5. So then you have a starting point, and then you can apply your slope to draw your other points. Okay, so before in mx plus b, our starting point was always the y-intercept. Now the starting point can be any point. Awesome. So, slope point form for a linear function then. Okay, so the equation of a line that passes through x1, y1, and with a slope of m, okay, is y minus y1, so we change the sign on the y1, equals m bracket x minus x1. Okay, change the sign on the x1. Okay, so let's practice this a little bit. So example 1, graphing a linear function given its equation in slope point form. Okay, so describe the graph of the linear function with this equation. Okay, so let's see. The slope is -1/2. Slope is -1/2. Okay, and then this goes through. So what point do we go through here? Okay, so this goes through. So the x coordinate comes first. So we have to switch the sign on this. So the x is 2. And the y coordinate there Okay, so we switch the sign on that, and we get -1. Oh, so it has a slope of -0.5 through +2, -1. Okay, and then part B says graph the equation. So if it goes through 2, -1, there's the point. So that's our starting point. And the slope is -1/2. So -1/2 means we go down 1, right 2. Down 1, right 2. Down 1, right 2. Again, that can be up 1, left 2, up 1, left 2, up 1. Okay, again, you only need 2 points to draw a line, so we've overkilled, but it does help if you use a ruler. Okay, either way, there is our line. Perfect. Okay, example 2. Okay, writing an equation given its line. Okay, so write the equation in slope point form for this line. Now, funny thing about this, there are 3 separate points for this. And the funny thing is that we can use any point for this. So there's going to be multiple answers for these things. It's not a big deal. Okay. So tell you what, I'm going to write the equation for all 3 points. You don't have to do this. You would just have to do it once. But I want to show you that they all work out to be exactly the same. So let's use this point here to start with. So that is the point -2, 2. -2, 2. Okay. Oh, we should figure out the slope too. So slope, okay, so from one point to the next, so down 1 and right 3. So down 1 is -1, right 3. So the slope is -1/3. So remember, the equation here is y minus y1 equals m bracket x minus x1. Okay, so then y1, okay, so we're saying that y1 is the y coordinate, so 2. So y minus 2 equals -1/3. Okay, and then x, now remember we changed the sign on these, so that's going to be -2 or just +2. Awesome, so there's one equation. Now, really, you can be done here. Okay, but I'm going somewhere with this. I want to show you that they're the same. So now I'm going to do this with the point. This is 1, 1. 1, 1. Okay, so that's going to be y minus 1 equals -1/3 x minus 1. Okay, and then the last point, that is the point 4, 0. So that's going to be y minus 0, okay, equals -1/3 x minus 4. Now, of course, that y minus 0, we don't usually write that, so 1/3 x minus 4. Okay, so there's 3 equations that mean the same line. Okay, now, so what I want you to do is I want you to write the equation in slope-intercept form. So that's the y equals mx plus b form. Okay, so in order to do that, I need to have y all by itself on the one side. Okay, so tell you what, let's call that equation 1. So y minus 2 equals -1/3 x plus 2. Okay, so let's change that into the right form. So the first thing we do is we distribute the -1/3. Okay, so -1/3 times x is -1/3 x, and -1/3 times +2 is -2/3. Awesome, so that's still y minus 2. So now we just have to plus 2. Okay, so y equals -1/3 x, and then -2/3 plus 2. So just go ahead and type that into your calculator if you want, or hey, if you can do fractions in your head, then perfect. So this guy here is plus 4/4. Okay, that's how that works out. Okay, so anyways, the y-intercept is 4/3. Okay, if we kind of have a look at the graph, whoa, that was weird. Sorry about that, guys. Okay, so 4/3, so 1, so this y-intercept, that looks like it could be 4/3, sure. Okay, that's reasonable. Okay, sorry, I zoomed in a bit there. Back, there we go. Awesome, so that's the first one. Let's try that with the second one. Again, you guys wouldn't have to do this, but I'm trying to prove a point. Okay, so the second graph, or second equation, y minus 1 equals negative a third x minus 1. So again, that just distributes. So you get negative 1/3 x. Now, negative 1/3 times negative 1 is positive 1/3. Okay, wow, I keep touching the screen and it zooms for us. So y minus 1 equals that. So then plus 1, plus 1. So y equals negative 1/3 x plus 4/3. Hey, that worked out to exactly the same thing. So even though we had two different point slope forms, it's the same slope-intercept form. Okay, and of course it's going to be the same way with this next one. So y equals negative 1/3 x minus 4. So that just distributes. So y equals negative 1/3 x. Now negative 1/3 times negative 4 is positive 4/3. So as you can see, the y-intercept, regardless of which form I started with, okay, they all, y equals mx plus b to the exact same equation. So y equals 4/3, so that is the y-intercept. Okay, so slope-intercept form, they all work out to the same thing. Perfect, even though in the point slope form, they were all different. Okay, they all had the same slope, but they all, when the line goes through different points, so you can pick a different point for the equation. Okay, anyways, long story short, and I'll write in blue, that equation, okay, that'd be called correct. This equation, that would be called correct. This equation, that would be called correct. So there's there's multiple different answers for a slope point form line. Okay, not a big deal, all good. How we usually get around that is we usually only give you one point, and then you have to use that point, and yeah, but really not a big deal. All right, next up. Okay, so writing an equation, I'm given 2 points. So the temperature in degrees Celsius is a linear function of the temperature in degrees Fahrenheit. Okay, the boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. The freezing point of water is 0 degrees Celsius and 32. So write linear equations to represent this function in point slope form and slope intercept form. Okay, so before we get started on this, we should try and identify who's who. Okay, the temperature in degrees Celsius is a linear function of the temperature in Fahrenheit. So what that means is that we have the temperature in degrees Celsius is some kind of function for degrees Fahrenheit. So some kind of function, so let's call that f of, and then it's just Fahrenheit, so let's say capital F. Doesn't matter, okay? The whole reason I'm doing this is that the Celsius is the y coordinate. So Celsius equals the y. That means that Fahrenheit would equal the x coordinate. So look, they've given us a couple sets of data here. Okay, so the Celsius is 100 degrees Celsius and 212 Fahrenheit. So that makes a point. So 212 Fahrenheit is 100 Celsius. So that's a point on our graph. Okay, we also have 0 Celsius and 32 Fahrenheit. So that is, so knowing that Fahrenheit is the x's, so 32 and 0. So those are our 2 coordinates. Now, if we get them backwards, like this would still work. It's just that would mean that the Fahrenheit is a function of Celsius. The other, we'd get it backwards. Okay, it would still give us the right answers for everything. It would just change our slope and change our graph, that kind of thing. Okay, so anyways, if I want to write it in point slope form, so the first thing I need to do is figure out the slope. Okay, so slope here, so let's call that, you know, I always pick that as the 1. So let's do this as x2, y2, just to mix it up a little bit. So this would be x1, y1. Okay, so y2 would be 100. 100 minus 0 over 212 minus 32. Okay, so either way, we get, that's going to be 100 over 180. Okay, and that reduces to 5/9. Okay, so again, when we want point slope form, we just pick one of the points. So remember, point slope form is y minus y1 equals mx minus x1. Okay, so the points here, okay, so if I use the x1 and the y1, so that's going to be y minus 0 equals 5/9 x minus 32. Okay, so that would work. Now, of course, y minus 0, we don't bother putting that, so 5/9 x minus 32. Okay, so that is one of the equations in point slope form. Now, again, we could have used the other equation, so that would have been y minus 100 equals 5/9 x minus 212. Okay, that is perfectly fine. We could use either one of those. It's not a big deal. Now, so that's good. The other other thing you could do is the y's are degrees Celsius, so we could have put degrees Celsius minus 100 equals 5/9 Fahrenheit minus 212. Okay, so if I really wanted to do that, I could put those letters in. We don't have to be stuck on the x's and y's, but it's okay. Okay, and then slope-intercept form. So basically, we're going to take one of these equations and then change it into y equals mx plus b. I'm going to choose to take this one because it's just easier. And the reason it's easier is because you don't have that 100 on the y. So that's 5/9 times x, and then 5/9 times negative 32. So on your calculator, I don't expect you to know this in your head. So 5/9 times negative 32, that works out to minus 160 over 9, which, you know, is 17.7 repeating if you really need a decimal. I would prefer you just leave it as the fraction, but this just gives you an idea of where that would be on the graph. It'd be negative 17.7 units down, so that would be the y-intercept. Okay, now using either equation, use either equation to determine the temperature in degrees Celsius at which iron melts, which is 2,795 degrees Fahrenheit. Okay, so we can use any of our formulas. I have 3 of them now. I have this guy, I have that one, and I have this one. Now, if you were doing this by yourself, you'd probably only have 2 because you would not have bothered to use both point slope formulas. Okay, so either way, we are going to, you know what, let's pick this one again. So y equals 5/9 x minus 32. Okay, and I like that formula because it doesn't have the y coordinate over there, and it doesn't have a crazy decimal like this guy, or a weird fraction, 160 over 9, like that's crazy. Okay, anyways, if I want this, so remember this could also be Celsius, is 5/9 Fahrenheit minus 32. Okay, so if I want the degrees Celsius, so that's 5/9, the Fahrenheit is 2,795 minus 32. Okay, so we just type that into our calculators and you get 1,535 degrees Celsius. All right, so that is that one. Pretty straightforward. Okay, next up, example 4, writing an equation of a line that is parallel or perpendicular to a given line. So write an equation that passes through 2, -3 and is parallel to the line y equals 3x plus 5. Oh, okay. So the first thing we have to do is we have to recognize that this line has a slope of 3. Okay, now, that isn't the line I want. Okay, that's the line that's given to us. So if it's parallel, remember, slope parallels are the same. So the slope parallel is also 3. So really, what this question is asking, it's a slope of 3 through this point, this other point. So through S to -3. So really, that's what this question boils down to. So it does not say which form of line it wants me to do. So point slope is really handy. The reason point slope is so handy is because you don't have to actually solve for b. Okay, so this guy, so we're going to use y minus y1 equals mx minus x1, again on your formula sheet. Okay, so y1 would be -3, so remember, change the sign on these. So it's y plus 3. Okay, now if you forget that, it would be y minus -3, so the two negatives would cancel and you get y plus 3 anyways. Okay, so if you forget, there's a little fail-safe there for you. So y plus 3 equals, the slope is 3, and then x minus 2. Okay, so there is the equation of your new line. So that goes through to -3 and is parallel to 3x plus 5. Parallel again has the same slope. All right, so what about if we want it perpendicular to 3x plus 5? Okay, so the slope here is 3. So the slope perpendicular then, okay, so that's 3 over 1. Okay, so that we're going to flip the fraction and change the sign. So that's going to be -1/3. So the slope I want is -1/3 here. So really, this equation is slope of -1/3 through s, which is 2, -3. So if you think of it that way, kind of chunk it out, it just makes it easier. Okay, so then again, the slope, or we're going to use that y minus y1 equals mx minus x1 formula. Okay, so y plus 3. Now this time the slope is -1/3. Okay, and then x minus 2. So there you have that line. So that is perpendicular to the line we wanted, 3x plus 5, and still goes through to -3. Awesome. So that is it. Okay, so we're done this section. I need you guys to practice this. It's section 6.5 in your textbook, starting on page 372. Again, print these pages from the workspace card, because then you can write all over them. It's just so much more convenient. Please show your teacher when you're done this. I know that seems like a lot of questions, but you need the practice on this. And remember, you can also do more if you want to. It's all good. So, show your teacher when you're done this. We'll see you next section. Thanks.